Chemical kinetics is a branch of physical chemistry. As you know, in chemistry, the three important branches are physical chemistry, inorganic chemistry and organic chemistry. When reactants get consumed, naturally its concentration decreases. When the product is going to form means the concentration increases. Some of the reaction, the stoichiometric coefficients and powers are same, but in few reaction, the stoichiometric coefficients and powers are not same. Hello everyone, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today, the third chapter of second PU Chemistry, that is Chemical Kinetics. Chemical Kinetics, first session. It's a physical chemistry chapter. In this chapter, today, I am going to explain or I am going to give an introduction about chemical kinetics. Going to give introduction about what? Chemical kinetics. Chemical kinetics. I'm going to give introduction about chemical kinetics. Second thing, I'm going to explain about rate of a reaction or velocity of a reaction. Rate of a reaction or velocity of a reaction, rate of a reaction or velocity of a reaction, rate of a reaction or velocity of a reaction. In rate, I am going to discuss about two types of rate, average rate and instantaneous rate. Average rate as well as what? Instantaneous rate. First, I will give an introduction about chemical kinetics. After that, I am going to explain about velocity of a reaction or rate of a reaction. After that, there are two types of rate, instantaneous rate as well as what? Average rate. Factors which affect the reaction rate. Dependence of rate on concentration. How the rate of the reaction depends on concentration. Rate constant of a reaction. Characteristic of rate constant. Rate is different, rate constant is different. Therefore, today's topic, in this session, I am going to give an introduction about chemical kinetics. I am going to explain about rate of reaction. Third one, average rate, instantaneous rate, factor which affect the reaction rate, dependence of rate on concentration, rate constant as well as characteristic of what? Rate constant. Now, when we consider the flow chart of this chapter, was the outline of this chemical kinetics. I'll tell you the flow chart. In chemical kinetics, the very important thing is reaction rate. Reaction rate or reaction velocity. Reaction rate or velocity. In reaction rate, there are three types: initial rate, average rate as well as instantaneous rate. Here I am going to explain about average rate as well as instantaneous rate. In reaction rate depends upon so many factors. If the reactions are very slow, if you want to increase the velocity of a reaction or rate of a reaction, what are the factors we are going to apply on that reaction? That is, whether we have to increase the concentration or decrease the temperature, or we have to increase the temperature or decrease the temperature. Then rate law. In rate law, I am going to explain about order, molecularity and rate constant. Order, molecularity and rate constant. And so, molecularity, then I will explain collision theory, then I explain temperature dependence of rate as well as zero order reaction and first order reaction. Okay, complete these all factors comes under chemical kinetics. Introduction. What is chemical kinetics? Chemical kinetics is a branch of physical chemistry. As you know, in chemistry, the three important branches are physical chemistry, inorganic chemistry and organic chemistry. Chemical kinetics is a branch of physical chemistry which deals with four factors. First one deals with rate or velocity of a reaction. Rate or velocity of a reaction. Second point, the factors which influence the rate. Factors which influence the rate. Third one, the mechanism of the reaction, how the reaction takes place, whether it takes place by single step or it takes place by two or more steps, that comes under reaction mechanism. And the theory about reaction rate. Theory about reaction rate. Therefore, under chemical kinetics, we have to study about how many points? 4 points. What are the 4 points? Rate of the reaction, the factors which influence the rate. Third one, the mechanism of the reaction. Fourth one, the theories about reaction rate. Theories about reaction rate. The first thing, we'll consider rate of chemical reaction. Rate of chemical reaction or velocity This rate or velocity we'll use in physics also. So in physics, we'll consider velocity of a light, velocity of wave. So when you consider light on an object or a wave, it displaces. So it goes from one side to other side. Therefore, in physics, the velocity is defined as it is a rate of change of distance with respect to time. Therefore, velocity of a light is equal to distance travelled divided by time taken. Therefore, the unit of velocity is meter per second. But in reaction, the reactant does not travel. It does not displace. So, reaction takes place. Reaction takes place. Reactant does not move. Reaction does not travel from one side to another side. Reaction takes place. Because if I consider a general reaction of the type, reactant give rise to product means as reaction progresses, the concentration of the reactant decreases. The concentration of reactant decreases and the concentration of product is increases. That means reactant get consumed. Reactant get consumed. Products are going to form. When reactants get consumed, naturally its concentration decreases. When the product is going to form means the concentration increases. Therefore, consider a reaction of the type R give rise to P, the reactant give rise to product. During the progress of the reaction, the reactant are consumed continuously and its concentration decreases and the product P formed and its concentration increases. My dear student, in your mind you fix that during a chemical reaction, the concentration of both the reactants as well as products get changed. Reactants decreases, product increases. Reactant decreases, product increases. Let us consider R1 and R2 be the concentration of the reactant R at time T1 and T2. R1 and R2 be the concentration of the reactants at time T1 and T2. The rate of consumption of the reactant is final concentration is R2, initial concentration is R1. R2 minus R1 divided by T2 minus T1 is equal to delta R divided by delta T. I'll put negative sign here. This negative sign does not indicate the magnitude. Negative sign indicates just it shows that the concentration of the reactant decreases. The concentration of the reactant decreases. Delta R is the decrease in the molar concentration of reactant, R in time interval delta T. When I consider the rate of formation of product P2 minus P1 divided by T2 minus T1, here I'll put plus. Therefore, plus delta P divided by delta T, where delta P is the increase in the molar concentration of the product. Therefore, velocity of a reaction or rate of reaction is nothing but plus or minus dx by dt. What is dx? Dx is the change in concentration, dt is the time. Dx is the change in concentration, dt is the time. dt is a small interval of time. Okay. Therefore, during chemical reaction, either both the reactants as well as product concentration changes. Reactant concentration decreases, the product concentration increases. Now, here from the graph, see my dear student, so observe the graph. What happens? The rate of formation of product, its concentration increases. The rate of disappearance of reactant whose concentration decreases. In this graph, you observe the concentration of product increases and the concentration of reactant decreases. Why concentration of product increases? Because here product is going to form. Why the concentration of reactant decreases? Here the reactant is going to get disappear. Next, what is rate of reaction or velocity of a reaction? Rate of reaction or velocity of a reaction is defined as it is the change in the concentration. It is the change in the concentration of any one of the reactant or product in unit time. There is a change in the concentration of one of the reactant or product in unit time. For example, when you consider rate, what is the formula? Change in concentration divided by time. The unit of concentration is mole per liter, time is second, so it will become per second. Therefore, the unit for velocity of a chemical reaction is mole per liter per second. But in physics, what is the unit of velocity of light? The unit of velocity of light in physics, that is meter per second. But the unit of rate of reaction is mole per liter per second. Okay, it is a unit for velocity of a reaction. Okay, so what's the formula for rate? Change in concentration divided by time. When we consider rate, I am going to explain about two types of rate. One is average rate, another one is instantaneous rate. Average rate and instantaneous rate. Average rate and what? Instantaneous rate. Let us consider average rate. Of a reaction. Let us consider the reaction of the type reactant give rise to product. So here also one we can give same definition. It is a change in concentration of any of the reactants or any of the product per unit time. When 1 mole of reactant R produces 1 mole of the product, if R1, P1 are the concentration of R and P respectively, time T1 at T1, R2 and P2 are their concentration at time T2. Therefore, delta T is equal to T2 minus T1, delta R is equal to R2 minus R1, delta P is equal to P2 minus P1. Rate of disappearance of R is equal to decrease in concentration of R divided by time taken, that is minus delta R divided by delta T. Now, rate of appearance of P is increase in concentration of product divided by time taken, that is plus delta P divided by delta T. Therefore, rate is equal to concentration change divided by time taken. And the unit of rate is mole per liter per second. Now, this rate of reaction is related with stoichiometry. The rate of reaction is always related with stoichiometry. Let us consider general reaction of the type A moles of A reacts with B moles of B, give rise to C moles of C and D moles of D. Small a, B, C and D are called as stoichiometric coefficients. They are called as what? Stoichiometric coefficients. They are called as what? Stoichiometric coefficient. Small a, B, C, D are called as what? Stoichiometric coefficient. Capital A and capital B are reactants. Capital C and capital D are what? Product. This rate of the reaction or average rate of the reaction is related with stoichiometry. How it related with stoichiometry? Already you know that for reactants we have to use negative sign. For products we have to use what? Positive sign. Why for reactants we have to use negative sign? Because during the chemical reaction, the concentration of the reactant decreases and the concentration of product what? Increases. Keep it in your mind, my dear student, wherever I'll put negative sign, the concentration decreases. This is for reactant. Wherever I'm going to put sign positive, here the concentration of the product increases. And you have to take this stoichiometric coefficient as its reciprocal. If it is here A, you write 1 by A and A is reactant, put minus delta A divided by delta T. Here the stoichiometric coefficient is B, therefore you take 1 by B and you put negative sign delta B divided by delta T. And here C, put 1 by C and it is product, therefore it is plus, so delta C by delta T. Here it is D, 1 by D, it is plus delta T divided by delta T. For example, when I consider 2HI give rise to H2 plus I2. Here HI is reactant, H2 and I2 are product. Therefore, for H, I had to use which sign? Negative sign. And here the stoichiometric coefficient is 2. Therefore, I had to take its reciprocal 1 by 2. Therefore, minus 1 by 2 delta Hi divided by delta T. And H2 and I2 are product. Therefore, I had to put which sign? Positive sign. Stoichiometric coefficients are what? 1, 1. For example, I'll consider formation of ammonia. Nitrogen reacts with hydrogen, give rise to ammonia. Give rise to ammonia. If after balancing, it will become 3H2 and it is 2NH3. For this, when a rate of reaction is equal to, here nitrogen and hydrogen are reactant. Therefore, I have to use minus sign. D of N2, that is delta of N2 divided by dt is equal to minus, here 3. Therefore, you have to write 1 by 3 delta H2 divided by delta T, delta H2 divided by delta T, and here it is 2, therefore you take 1 by 2 and it is a product, you put plus delta NH3 divided by delta T. Therefore, for all reaction, put negative sign for reactant, put positive sign for product, and stoichiometric coefficient, you have to take its what? Reciprocal. Second one, I am going to explain about instantaneous rate of a reaction. Instantaneous rate of a reaction. It is the rate of change of same concentration of reactant product at particular instant of time. This is very, very important. At particular instant of time. What's the difference between average rate as well as what? Instantaneous. Average rate at unit time, any time. But instantaneous rate is at particular instant of time. This is also instantaneous rate also minus dr by dt is equal to plus dp by dt. Same if I consider the general reaction of the type AA plus BB give rise to C moles of C as well as D moles of D. It can be written as minus 1 by D of concentration A divided by dt is equal to minus 1 by B concentration of B divided by dt plus 1 by say dC divided by dt 1 by D dt divided by dt. Therefore, unit of reaction of both instantaneous rate and average rate is mole per liter per second. Now, the second type rate I express, that is instantaneous rate. How do you going to get instantaneous rate? Instantaneous rate. This instantaneous rate is obtained by using graph. Plot a graph of concentration versus time. Plot a graph of concentration. Instantaneous rate of a reaction is determined by graphically by measuring the slope of the tangent drawn at the point that corresponds to the given instant of time to the curve of the concentration of reactant versus time as shown in the graph. Please, my dear student, plot a graph of concentration versus rate. You will get curve. For that you draw tangent. For that you find out slope. Slope is nothing but instantaneous rate. Slope is nothing but what? Instantaneous rate. Therefore, how do you get instantaneous rate by graphical method? By measuring slope for the tangent which is drawn to the curve. How can you get this curve? By plotting a graph of concentration versus what? Time. This is the graphical method to find out instantaneous rate. Some of the factors, for example, some of the reactions are slow, so you have to increase its velocity. However, what are the factors I want to apply on the chemical reaction to influence the rate or increase the rate? The first factor, nature of reactant. The reactions involving polar and ionic substances are quite fast, whereas involving covalent compounds are slow. Ionic reactions are fast compared to covalent. When ionic compounds are involved, the rate of reaction is fast, more. So, when covalent compounds are involved, they are slow. Okay. Next, second part is concentration. I'll explain how concentration influences the velocity. Third one, temperature. Fourth one, presence of catalyst. So, in depth, I'll explain how concentration affect the rate of reaction, how temperature affect the rate of reaction, how the catalyst affect the rate of the reaction in next session. In future sessions, I am going to explain about what's the effect of concentration, temperature, catalyst on the rate of reaction. Only when I consider nature, when they are ionic substances, the reaction are fast compared to when the substances are covalent. substances are covalent. Okay. Next, rate law. This is very important. To explain rate law as well as rate expression, rate law or rate expression, rate law or what? Rate expression, you require the help of, so the first PUC one chapter, that is chemical equilibrium. Under that chapter, so you know that one law that is known as law of mass action, law of mass action, law of mass action. So according to LMA, you are going to write it as what? LMA. In future, in physical chemistry, if I mentioned LMA means, it indicates what? Law of mass action. Today, now I am going to explain about rate law as well as what? Rate expression. To explain rate law as well as rate expression, you require the help of law of mass action. What is rate law or rate expression? It's an expression which gives relationship between rate and concentration, rate of reaction, concentration of reactant, concentration of what? Reactant. So the representation of rate of reaction in terms of concentration of the reactant is known as rate law. It is also called as rate equation or rate expression. Rate law is also called as rate equation or rate expression. What is rate law? What is rate equation? What is rate expression? It gives the relationship between rate of reaction, as well as concentration of the reactant, rate of reaction and concentration of the reactant, rate expression and rate constant. Law of mass action, expression in which reaction rate is given in terms of molar concentration of reactants. So here when I consider reaction of the type, here AA, BB, CC, the velocity according to law of mass action, velocity is directly proportional to product of the molar concentration of the reactants, raised to the powers may or may not be equal to stoichiometric coefficient. Here stoichiometric coefficients are A and B. Here I had written X and Y. Here I had written X and. What does it mean? Some of the reaction, the stoichiometric coefficients and powers are same. But in few reaction, the stoichiometric coefficients and powers are not same. Therefore, so this how I can write this expression. This is from law of mass action. Was the statement of law of mass action? At constant temperature, the statement of law of mass action or law of mass action states that at constant temperature, the velocity of a chemical reaction directly proportional to product of the molar concentration of the reactant raised to the power is equal to may or may not be equal to stoichiometric coefficient. For example, when I consider general equation of the type A moles of A reacts with B moles of B give rise to C moles of C plus D moles of D, where AB, as I told you, A, B, C, D are stoichiometric coefficients of reactant and product. Rate expression for this reaction, rate is directly proportional to molar concentration of A into molar concentration of B to the power of X and Y. What does it mean? It may or may not be equal to stoichiometric coefficient, where exponents X and Y may or may not be equal to stoichiometric coefficients A and B of the reactant. Above equation written as what? Rate is equal to K into molar concentration of A to the power of X, molar concentration of B to the power of Y, where X and Y, the powers may or may not be equal to stoichiometric coefficients A and B. Okay. So here I had written this expression by taking the help of which law? Law of mass action. My dear student, once again I will give the definition for rate law, rate equation and rate expression. It gives the relationship between rate of reaction and concentration of the reactant. Rate of reaction and concentration of the reactant. So if I write V is equal to K into molar concentration of A into molar concentration of B to the power of X and Y, where V is called as velocity or rate, K is called as velocity constant. K is called as velocity constant or rate constant. Velocity constant or what? Rate constant. Okay. Here my students, V is equal to velocity or rate. Velocity or rate. K is equal to velocity constant or rate constant. K is equal to velocity constant or rate constant. This equation relates the rate of reaction and concentration of the reactant. So instead of V minus dr by dt, T of molar concentration of reactant and K, now this equation is called as differential rate equation. In place of velocity, if I substitute minus dr by dt, then it is called as what? Differential rate equation. Then it is called as what? Differential rate equation. Differential rate equation. Okay. When we consider V is equal to K into molar concentration of A and molar concentration of B to the power of X and Y, if I consider molar concentration of both A and B as unity or 1 mole per dm cube or 1 mole per dm cube, this has how many mole? 1 mole, then V become K. V become K. Therefore, what is rate constant? Rate constant is equal to the rate of the reaction when the product of the molar concentration of the reactant is unity. When the product of molar concentration of the reactant is unity, the rate constant is nothing but the velocity of a reaction. For example, when we consider 2NO plus give rise to O2 plus 2NO2, it can be, rate equation can be given by rate is equal to K into NO to the power of 2 into, if I consider, so example 2NO plus O2 give rise to 2NO2, give rise to 2NO2. So here velocity is equal to K into molar concentration of NO into molar concentration of 2. Here the stoichiometric coefficient is 2. Here the stoichiometric coefficient is 1. Therefore, the rate minus dr by dt is equal to K into molar concentration NO to the power of 2, O2 to the power of 1. The character of rate constant, higher the value of K, higher will be the velocity, because velocity and velocity constant are directly proportional to each other. If you want to find out which is the fast reaction, means which has high value of K, V and K are directly proportional. A particular reaction definite value of our particular temperature. So the value of rate constant increases with temperature. K is directly proportional to T. As temperature increases, the velocity constant also increases. It does not depend upon initial concentration. K does not depend upon initial concentration of the reactant. Initial concentration of the reactant. It unit depend upon the overall order of the reaction. Here I used one term order. In next session, I will explain what is order of the reaction. It's a new term for you, my children. So, order of the reaction. So, therefore, here we have to find. So, as K increases, the velocity also increases. As temperature increases, the velocity constant also increases. It's a characteristic of what? Rate constant. So, today in this session, okay, in the first session of this chemical kinetics, I had given introduction about chemical kinetics, as well as I explained what is velocity of a reaction and as well as a rate of a reaction. I discussed about two types of rate, that is average rate as well as instantaneous rate, how they related with stoichiometric coefficient. So for reactant you have to take minus, for product is you have to take plus, and stoichiometric coefficients you have to take as a what? Reciprocal. Then I had taken rate law, rate expression and rate equation. From that I deduce rate constant as well as characteristic of what? Rate constant. Today I completed these basic things of the chemical kinetics, that is in the first session. And the next second session I am going to come with a new concept, that is order and what? Molecularity. Goodbye. Thank you.